Hello there, I'm Stephanie Enriquez Viva of ESED Math 3.2. In this video, we're going to tackle about the multivariable chain rule under the functions of several variables. But first, what is a chain rule?
The chain rule is the rule we use if we want to take the derivative of a composition of functions. The chain rule for functions of more than one variable involves the partial derivatives with respect to all the independent variables.
Tree diagrams are very useful in deriving formula for the chain rule of more than one variable, where each independent variable also depends on the other variable.
Let z equals f of x and y, x equals g of t, and y equals h of t, where f, g, and h are differentiable functions. Then, z equals f of x and y equals f of g of t, and h of t is a function of t, and this would be the formula.
So to further understand, we're going to use a tree diagram to find the dz over dt, or the partial derivative of z with respect to t. So here, we're going to draw a tree diagram. So this is z as a function of x and y. So as we can see here, there are two branches, where the first branch, x, is also a function of t, the same as y. So we have here the tree diagram according to the theorem 107. So the first thing to do is we have to find this branch. So we can have here this partial derivative of z with respect to x, or shall we write as dz over dx. So this would be number 1. So we have the number here to be clear. And then the second one is we have to find this branch. So we have here dx over dt. So we have to write this one. dx over dt. Since we've already finished, then we have to proceed to the other branch. So we have the number here. So we have the partial derivative of z with respect to y. So we have dz over dy. And the last one is to find the partial derivative of y with respect to t. So we're going to write as dy over dt. So we have here already. Now, by using the theorem 107, so we have to rewrite this one. So by theorem 107, so the formula in finding the partial derivative of z with respect to t is equal to the partial derivative of z with respect to x. So we have here the number 1 times the partial derivative of x with respect to t. We have here the number 2 plus the dz over dy, or the partial derivative of z with respect to y, times the dy over dt. So this would be the formula that we are going to use in finding the multivariable chain rule according to the theorem 107.
Example: use the chain rule to find the partial derivative of z with respect to t. So we have here z equals x cubed y plus 3x squared, y cubed, x equals 4 plus t squared, and y equals 5t cubed. By using the formula in the theorem 107, we have dz over dt equals dz over dx times dx over dt plus dz over dy times dy over dt. So we're going to differentiate this function, but we're gonna treat y as a constant and differentiate only x. So we have dz over dx equals 3x squared times y plus 6x times y cubed. So equals to 3x squared y plus 6x y cubed. So we have dz over dy. Here, we're gonna treat x as a constant and differentiate only y. dz over dy equals x cubed times 1 plus 3x squared times 3y squared equals x cubed plus 9x squared y squared. So next is we have to determine dx over dt and dy over dt. So we have here the value of x equals 4 plus t squared. So the partial derivative of x with respect to t equals 2t. And y, we have 5t cubed. So dy over dt equals 5 times 3t squared equals to 15t squared. Now have everything that we need in order to find the dz over dt. So now let's substitute. So the value of dz over dx, we have 3x squared y plus 6x y cubed times the value of dx over dt. So we have here 2t plus the value of dz over dy, we have x cubed plus 9x squared y squared times 15t squared. So we have to do the distribution property. So we have 3x squared y times 2t plus 6x y cubed times 2t plus x cubed times 15t squared plus 9x squared y squared times 15t squared. So we have to multiply this one. 6x squared yt plus 12x y cubed t plus 15x squared x cubed t squared plus 135x squared y squared t squared. So reduce it in the simplest form. 2x squared y t plus 4x y cubed t plus 5x cubed t squared plus 45x squared y squared t. So this is our answer.
So, here's another tree diagram that is quite similar to Theorem 107. But the only difference is that when x was the function of t only, this time x is a function of s and t. The same with y is a function of s and t. So this would be the formula for the Theorem 108. So the first thing we're gonna do is to look, or we have to focus on everywhere we see an s. So to find dz over ds, or we have the partial derivative of z with respect to s. So we have here, we have to locate to z over x, and we have dz over dx times dx over ds. So we have to go with this particular branch plus dz over dy. We have here dz over dy times dy over ds, or the partial derivative of y with respect to s, as we go along with this branch. So this would be our first formula in the Theorem 108. So what is written here is just the same here. I just rewrite it. So the second thing we are going to do is to focus on everywhere we see t. So let's find the branches where there's t. So the formula is dz over dt, or the partial derivative of z with respect to t. So we have dz over dx, same with the first formula, times dz dx over dt, since we are already focusing on t, plus dz over dy, same with the dz over ds, times dy over dt. So this would be our second formula.
So here is an example. Z equals 4x cubed, y raised to the power of 5, x equals 3s squared t, and y equals 2s cubed t squared. So we are going to find the partial derivative of z with respect to s and partial derivative of z with respect to t. So again, we need to focus on everywhere we see an s. So in order to find the partial derivative of z with respect to s, so we are going to use the formula dz over dx times dx over ds plus dz over dy times dy over ds. So first, the partial derivative of z with respect to x. So we have 4 times 3x, y raised to the power of 5 equals 12x squared, y raised to the power of 5. And then we have dx over ds, derivative of 3s squared t. So we have here 3 times 2s t equals 6st. And then we have dz over dy equals 4x cubed times 5y raised to the power of 4. So the answer would be 20x cubed y raised to the power of 4. And then the last one, you have partial derivative of y with respect to s. So we have dy over ds equals 2 times 3s squared t squared equals 6s squared t. So let's plug in everything into this formula. So we're going to substitute the value. So we have dz over ds, 12x squared y raised to the power of 5 times 6st plus 20x cubed y raised to the power of 4 times 6s squared t squared. So the answer would be 72x squared y raised to the power of 5 st plus 120x cubed y raised to the power of 4 s squared t squared. Since we already have the value of partial derivative of z with respect to s, so let's proceed to the partial derivative of z with respect to t. So the formula is dz over dx times dx over dt plus dz over dy times dy over dt. So now let's do the math. So the partial derivative of z with respect to x equals 4 times 3x squared y raised to the power of 5. So we have 12x squared y raised to the power of 5. And then you have dz over dy equals 4x cubed times 5y raised to the power of 4. So the answer is 20x cubed y raised to the power of 4. Then the value for the partial derivative of x with respect to t. So we have here 3s squared times 1, and dy over dt we have 2s cubed times 2t equals 4s cubed. So we're going to substitute everything in the formula. So we have here dz over dt equals 12x squared y raised to the power of 5 times 3s squared plus 20x cubed y raised to the power of 4 times 4s cubed t. So the answer is 36x squared y raised to the power of 5 s squared plus 80x cubed y raised to the power of 4 s cubed t. So this is the value of the partial derivative of z with respect to t.
By applying this concept, we need to find the critical points, the saddle points, and the local extreme values of this multivariable function. Let's go over with the steps that we need. So the first one is we need to identify the points of interest. So we have here C, point A, and B. This point could be critical or the saddle point, and this point of interest can only be found when the partial derivative with respect to x equals 0 and the partial derivative with respect to y equals 0. So we need to calculate the d, and by finding this d, we have to solve the second partial derivatives. So d equals f of double x times f of double y minus the partial derivative of x y squared. So now that we have the value for d, so we can now identify the points that we have. If d is greater than 0, f of double x is greater than 0, the function evaluated as a, b is a local minimum. So this would be the first case. So the second case is if d is greater than 0 and f of double x is less than 0, then the function evaluated as a, b is a local maximum. However, in the third case, if d is negative, no matter what the value of the f of double x is, the function of a and b is neither a local maximum nor a local minimum. But the point a, b, so we have here the point a and b is the saddle point.
We have example. Given that the function of x and y equals 10 minus 3x squared minus 2y squared plus 8y plus 12x. So identify any critical points, saddle points, and any local extrema. So first, we have to find partial derivative with respect to x. So we have 10 is constant, so it will be 0. The derivative of 3x squared is negative 6x. 2y squared will be treated as constant, and the derivative of 12x is 12. So we have negative 6x plus 12 equals the value of x is 2. Second is we have to find the partial derivative with respect to y. So 10 minus 3x squared and the 12x will become 0 since they will be treated as constant. So we're gonna set f of y equals to 0. So we have negative 4 times y minus 2. So the value of y is 2. So the next thing to do is to calculate the second partial derivative. So we're going to calculate f sub double x. It equals to 6. The same goes with the f sub double y. So we have negative 4. So now we're gonna calculate the mixed derivative. So now let's substitute everything to the formula. So the answer would be 24. So after that, we have to substitute our points. As we have solved earlier, we have 2, 2 in the function. So the answer would be 30.
So that could be all for this video. I hope that you have learned something. Again, this is Stephanie Viva left you with the saying that
Dream to live and live your dream.